Welcome to Meowing Clinic. How can I help you?
Please help my Milo. He fell and now he's not responding.
Okay, calm down. Let me see what we can do. Good news, Dr. Josephine is available right now. A nurse will guide you to a room shortly. Right this way, please.
Hi, good afternoon. I'm Josephine, a senior vet here. How can I help you today?
Hello doc, this is Milo. About an hour or two ago, he fell down the table and he won't wake up, so I panicked and rushed him here.
Well, you came to the right place. I can assure you Milo is in good hands. Now let's check up on him first to see what's wrong.
Off you go now, Milo.
So based on the x-rays and examination results, it seems that Milo's condition is due to internal injuries, so it's best for us to take action and immediately operate on him to minimize further complications.
Operate? But wouldn't that hurt him, doc?
Just like humans, animals have anesthesia too, so you don't need to worry as he won't feel a thing.
Okay then, doc.
Anesthesia is the reduction or complete loss of response to pain, consciousness, and muscle movement during medical procedures caused by anesthetic drugs. Isoflurane is a form of general anesthetics which causes the whole body to lose feeling, movement, and consciousness. It is frequently used in surgeries for humans as well as veterinary anesthesia and is taken up by inhalation. Its anesthetic effects are due to targeting GABA-A receptors, potassium channels, and NMDA glutamate receptors in the body.
Before we get into the mechanism of isoflurane, we must first understand the basics of what anesthetic drug commonly targets, which is our nervous system. Our nervous system is made out of interconnected neurons, which are specialized for the rapid transmission of impulses throughout the organism. These neurons carry impulses from our receptor cells found in sensory organs. The impulse provides information on the internal and external environment and sends it to our central nervous system, which is the brain or spinal cord. Here, they process and relay information for neurons to carry an impulse to specialized effector cells, such as muscles or glands, which initiate response.
Nerve impulses are conducted along the neuron through the resting and action potential. These involve the electrochemical gradients between the inside of the axon and the outside. When an impulse passes through, the axon changes its membrane permeability to sodium and potassium ions, involving sodium and potassium channels, as well as a sodium-potassium pump, which causes change to its polarity and potential difference.
As the impulse reaches the end of a neuron, it has to travel across the synapse, a junction where two neurons meet. These depend on the movement of calcium ions. The arrival of an impulse at the synaptic knob will increase permeability of the presynaptic membrane to calcium ions, as the calcium ion channels open up and allow the ions to move in. Calcium ions will then bind to synaptic vesicles containing neurotransmitters, moving it to the presynaptic membrane and releasing neurotransmitters into the synaptic cleft. Neurotransmitters will then bind to neurotransmitter receptors on the postsynaptic membrane, causing ligand-gated channels in the membrane to open, which results in sodium ions flowing into the nerve fiber, creating a change in potential difference and generating an action potential down the neuron.
Anesthetics such as isoflurane, which prevents us from feeling any pain during medical processes, usually disturb these processes of the nervous system. Inhalation anesthetics, specifically, exert their effects by binding directly to the ion channels.
We will now move on to the action of isoflurane towards our nervous system in detail as it is inhaled to the body. Isoflurane is a halogenated volatile anesthetic that is potent in producing immobility. Previously mentioned, studies suggest that this anesthetic produces unconsciousness via gamma-aminobutyric acid type A receptor subunits, GABA-A for short, activating two pore domain K+ channels, and inhibiting NMDA receptors.
GABA-A receptors are located both postsynaptically and extrasynaptically on the majority of neurons in the central nervous system. They are composed of pentameric arrangements of subunits around a central ion channel pore. When endogenous GABA-A is released from one neuron, it binds to the neighboring neuron's GABA-A receptors. This causes the opening of the central pore, allowing chloride ions to pass down electrochemical gradients and result in the hyperpolarization of the neuron. Therefore, it would be more difficult for excitatory neurotransmitters to cause depolarization and generate an action potential down the neuron.
Isoflurane binds to GABA-A receptors to enhance the inhibition of neuronal activity by keeping the central pore open longer, thus making the charge far more negative and harder to generate action potentials. This makes the patient unconscious and immobile during the operation.
Two pore domain potassium channels regulate the resting potential of neurons. Similar to how it targets GABA-A receptors, isoflurane prolongs the opening of these channels, which leads to increased potassium efflux, thus making it difficult to depolarize the neuron and produce an action potential. This keeps the patient neurons in a resting potential state and reduces neuronal excitability.
Another way isoflurane exhibits its effects is through N-methyl D-aspartate receptors, NMDA receptors for short. These are located in the spinal cord and are crucial in pain modulation and processing.
When neurotransmitter glutamate binds to NMDA receptors, it causes inflow of extracellular calcium ions into the postsynaptic neuron, which activates a series of signaling molecules, causing pain signals to increase and fire more frequently.
Isoflurane may inhibit NMDA receptors, which prevents or decreases neurotransmission of pain. Therefore, patients won't feel anything during the operation.
Other ways in which isoflurane causes anesthesia include acting as a positive allosteric modulator of GABA-Y receptor, potentiates glycerin receptor activity, which decreases motor function, activates calcium ATPase by increasing membrane fluidity, as well as binding to D subunit of ATP synthase and NADH dehydrogenase.
This way, isoflurane ensures human and animal patients will go under anesthesia and not feel any pain during surgeries.
So the operation went well and now Milo is free to go home.
Thank you, Doc.